plus 7, 1 plus 4i over n. So first prep, delta x, 5 minus 1 over n, prep to xi, the lower limit, plus I delta x, and then I have to plug in xi in the function. So 6 times the x squared plus 7 times x. And I have to fully simplify this. So I have 6. Remember, we have 3 terms here. 1 plus 2 times the first times the second is 8i over n, and then plus 16i squared over n squared. And then plus 7 and plus 28i over n. And we are on page 10. Okay, so let me see. There is only one squared term, 96i squared over n squared. So this is accounted for. 48 plus 28. Is it 76? Please correct me. I over n. So these two are accounted for. Is it? So it's 48.
Yeah, 48 is 76.
Good. Okay, so now I have 6 plus 7. So everything is accounted for. I multiplied, I added, I multiplied, and 6 plus 7. Okay. Only now I can write the area as the limit as n approaches infinity from the sum from delta x, which I will already put in front, and then the sum of this from the first subinterval till the last subinterval that will eventually go to infinity, from 96i squared over n squared plus 76i over n and plus 13. Okay. So now limit n approaches infinity 4 over n. So I'll take this in front when I apply the sum. So 96 over n squared, the sum of I squared, plus 76 over n, the sum of I, plus 13n, we know that already. Now this and this will be replaced. And they will be replaced by n. I will already multiply, or let me show it first. And this one by n plus 1 over 2. So now these disappear. So limit as n approaches infinity 4 over n from 96n squared times n. Now I will multiply these two. 2n squared plus 3n plus 1 divided by 6 plus 76 over n times n plus 1 over 2 and plus 13n. Okay, I want to simplify, but not everything. N still has to stay. So this will be 38 and this will be 16, right? Yes. And I will cancel out one n. And this will also take an n because it has denominator 1. So the denominator will be, the least common denominator will be n. So now 16 times all these three terms. So 32n squared plus 48n and plus 16 plus 38 multiplied, I have to have the n, by, so 38n squared plus 38n and plus 13n squared. For the first time ever, I fit it in one row. Hope you're proud of me. Okay. And that's 11. Okay. So then limit n approaches infinity 4 over n squared. Okay, let's see what we get. So the 32 plus 38, and that's 70, plus, so 83. Okay, now I have a 48 and a 38. That's 86. And 16. Again, we can go through all those steps. It's infinity over infinity. I differentiate, but the answer will be 4 times 83. If 4 times 83 equals 332, I'm in business. If it does not equal 332, 2 and 1, 332. So is this okay, Mark?
Yeah, that'll help me try to figure out all the steps a little bit better.
Good. Other questions? Other questions? So the only one that we haven't touched up on is finding derivatives of functions that are given as an integral. Do you want to do this one? You don't want to do any?
Let's definitely do one.
Do you want to choose one?
What chapter was that?
It's in 5.4. Or you want to use this or choose another?
Let's start with that one.
Okay. So this one, it's g of x, the integral from x squared to tangent x from t squared dt. Perfect. Good. So this is not set up yet. So this is the integral from x squared to whatever you want from t squared dt plus the integral from the same thing to tangent x t squared dt. This is fine for differentiation, but this is not. I have to flip, and I change the sign. So x squared t squared dt plus tangent x t squared dt. And now I can differentiate. Finally, g prime of x would be negative. Plug it in. X squared squared will be x to the fourth, but then times the inner function prime. And then plus, plug it in, tangent x squared times the inner function prime, secant squared x. I will just rearrange it as negative 2x to the fifth, and I will leave this alone, plus tangent squared, secant squared. And that is it. Next question. Anything else?
Can you move the paper up a little bit?
Like this? This direction?
Yes, perfect. Thank you.
Anyone else has any questions, anything?
Yeah, in the moment you can copy. I want to go back to the end of the previous song that you just did.
Yes? The previous problem, Oscar?
Yes, that one. No, the other page. Okay. That's okay. What happened to the 86 and the 16?
This one? And 16. Okay, very good. So let's talk about that. So, from this situation, from this step, I will continue here. So I know it's infinity over infinity, so then I have limit as n approaches infinity, and I put a 4 in front. It's a constant. You can wait patiently. So I differentiate the top because it's infinity over infinity, and I get 166n plus 86 divided by 2n. It's again infinity over infinity, so I have 4. Limit as n approaches infinity. I differentiate the top and I get 166. I differentiate the bottom and I get 2. And this is 83. So it's 4 times 83, which is the same thing, 332.
Thank you.
You're welcome, sure.
Sorry, can I see the last problem that we did?
Of course. Also, don't forget I post this after class. Everything we do. And the videos and everything. Just in case you need to review. Anything else?